Hello again. Well, now I'm on to the second part of question 40, which is having found the points of intersection of these two curves. Now we have to find the exact value of the area enclosed between the two curves. Now notice this is worth 4 marks and it's in the calculator section, so the calculator can be used at some of this, but you must show some working as well for any question that's worth more than 2. So what I'm going to do here is I think I'll just do it all with the working, but you would certainly be sensible to use your calculator along the way. I will start it off. Here we go. Find the exact value. Well, the area is the integral between, now the first 2 points are the points 1 and 0, of, now we need the upper one, which is q of x, so that's the x squared plus 5x minus 12, minus the lower one, which is minus the minus 12 cos, well, minus 12 will be plus 12 cos pi x on 3. That'll be the area in there between the first 2 points. So that's that first bit, plus, now we need the area in the second section, which is the integral between 3 and 1. Now the upper one this time is p of x, which is the negative 12x, negative 12 cos pi x on 3, minus the other one, minus q of x, so it's minus x squared minus 5x and plus 12. That's with respect to x, and there should be a dx on the end of that one as well. Okay, that's the two things that I have to integrate, and I have done the subtracting the one function away from the other in both those sections whilst I did that. So now let's go down and do a bit more integrating. So that area equals, I'm going to need a bit of space here, it looks quite long, so the area equals, now this is going to be between 1 and 0. So the first one, we've got, that'll be x to the 3 over 3. Second bit will be plus 5x squared over 2. That'll be minus 12x. Now the integral of a cos is a sine, so this will be plus 12 sine whatever the angle is, pi x on 3, all divided by the derivative of the inside part here, which is pi on 3. And that is all between 1 and 0. Plus, now the integral of the second lot, well, I've got negative cos, so there we go, that'll be negative 12 sine pi x on 3, again divided by the pi on 3, minus x to the 3 over 3 minus 5x squared over 2 plus 12x. And that is between 3 and 1. So I think the message here is you just got to be real careful. Each little part, just think about it carefully, try not to miss out any minus signs and all that stuff as we're going along. Now we're going to start substituting in the 1 and the 0 and the 3 and the 1 and just see where it all comes to. So here we go. Putting in 1 into this equation, I will get 1 on 3 plus 5 on 2 minus 12. Right, 12 divided by pi on 3, if I just, somewhere over here, 12 divided by pi on 3 is the same as 12 times 3 on pi, which is 36 over pi. So what we get here is plus 36 over pi times the sine. Now putting 1 in, we get pi on 3. So that's putting the 1 in. Then we take away the same lot when we put 0 in instead of x. But I'm not going to do anything there because that'll give me 0, that'll give me 0, that'll give me 0, and sine of 0 is also 0, so it's just going to be taking away 0 when I put 0 into this first expression. So that's the first bit all done. That's getting a bit simpler. Now, the area is that plus. Now I've got to put 3 into this expression. Okay. So again, we get the minus, we get the 36 on pi for the same reason we did in the previous one. That's that division by pi on 3. Times the sine this time, when x is 3, we get 3 on 3, which is 1, so we get the sine of pi. Then we put 3 into the next bit. We get minus, that's 3 cubed, that's 27 over 3. Then we put 3 into the next bit. 3 squared is 9, 9 5s are 45. And 3 into that bit, 12 3s are 36. That's that lot. Minus, same thing, when we put 1 in instead of the x. So we get negative 36 on pi. Sine, this time we're going to get sine of, when we're 1, we're going to get sine of pi on 3. I'll have to carry on to the next row, I don't have room. Minus, when 1 goes to that, 1/3, minus 5 on 2, plus 12. And again, here we go. What's this all come to? Right, hopefully some things will start cancelling out or something. Anyway, let's just see. Just looking, what I'm doing is I'm looking across the whole lot here to see if I can see some things that are going to cancel out. That'll be 9, 36, a third minus, that'll be plus. I'm not seeing too much cancelling. Okay, I'm just going to have to work it all out bit by bit and then combine it at the end. I'm trying to make it easy for myself, but I can't see anything that is, so okay. Let's change the third and the half part into sixths. So I've now got 2 sixths plus, that's multiplying that one by 2 on 2, this by 3 on 3, that's 15 sixths minus 12 plus 36 on pi. Now sine of pi on 3, hopefully you can remember that the sine of pi on 3, a little triangle here, 2, 1, root 3, there's pi on 3, sine of that is root 3 on 2, minus the 0. Then we've got minus, oh well, this is going to be 0 because the sine of pi is 0, so that's minus 0 plus 0 for that bit. We've got minus 9, that's 27 on 3, then we've got minus 22.5 plus 36, minus minus changes that into a plus, and as before, sine of pi on 3 is root 3 on 2, minus, the minus outside this last bracket, so that's why that changed to a plus. We're also going to get plus, well, I might go to 6 because I did before, so plus another 2 on 6 plus 15 on 6, and oops, that should be a minus because it's minus outside the bracket and there, minus 12. Well, I've got rid of all my brackets, now I've just got to combine it all to see what I've got. Area equals, right, I've got 2, 6, let's add up my 6, I've got 15, 16, 17, and 17 is 34 on 6. I've got minus 12 minus 9, that's minus 21. Minus 12 is minus 33. Plus 36 is plus 3. Minus 22.5. That's the numbers part. Now, the whole numbers part. Now the other bit I've got Now I've got two lots of this same expression. 2, so I've got plus 2 lots of 36 on pi times root 3 on 2, and those 2's are going to cancel. Right, now we're just going to make sense of this lot over here. I've got halves and I've got 6, so we're going to have to, let's just do it in my head. We go 6 5s are 30 and 2/3. Okay, I'm going to need 6ths to combine these two, so I'll just leave it, I'll put it all into 6. I've got 34 on 6 plus, put that in 6, that'll be 18 on 6 minus, I'll go back to 45 on 2, change that to 6 by multiplying by 3 over 3. That gives me 45 times 3 is 135 plus 36 root 3 on pi. Right, let's see what I've got here. Now 34 and 18 is 52. 52 minus 135. Okay. 135, I'm doing it the other way around and then just put a minus sign with it. 135 minus 52. 3, 5 is 8. It's 83, so that could be negative 83. So the area, finally, is negative 83 on 6 plus 36 root 3 over pi square units. That's as an exact value. That is terribly long, terribly slow. I would expect you to use a calculator at some stage to make that a whole heap quicker. Now for your 4 marks you have to show some working, so I suggest, if I put in a different colour the bits that you would absolutely want to show, I would put this line to show you working. I would even put this line to show you working. By doing that you demonstrate clearly that you know exactly what you're doing with these type of things, but then finally I think you could skip most of the rest of that and you could go straight down to that line then. I think it would be very harsh for an examiner not to give you full marks since you've clearly demonstrated that you know what you're doing exactly here. And it is the calculator section and they are expecting you to use it. I've done all this just to show you the algebra of this thing, but I wouldn't expect you to do that yourself in an exam.